Okay, so I'll start. Thank you very much for giving us the opportunity to give this talk today. So my name is Ariane Stratmann and this is Alex Johny, and we both work at the Center for Proper Housing for Poultry and Rabbits, and that is part of the Division of Animal Welfare at the University of Bern in Switzerland. And we are going to talk today about improving welfare by designing housing systems from a chicken's perspective. And that is part, like most of the studies that we present are either done by me and Alex is currently a PhD. So I'm a postdoc in this group and Alex is a PhD student. He's starting his third year now, and we will actually talk about the research that we have done so far. Wait, here, right? Good. So in this picture here, you see a modern laying hen hybrid, and due to a very intense and specified selection process over the last decades, this bird is actually able to produce more than 300 eggs a year. And in fact, it is one of, next to the broiler, it's one of the most common bird worldwide. We have about 6.6 billion birds producing more than 6 billion eggs for consumption a year. And then what all of these laying hens have in common is the ancestors. So they all stem from the red jungle fowl, which is a bird that lives in the southeast of Asia in small flocks of 5 to 8 hens with a rooster. And also, although the bird, so the modern laying hens differ tremendously in terms of the egg production and other features, the behavioral needs and the behavioral repertoire is not that much different towards or compared to the red jungle fowl. So in terms of the behavioral repertoire, I want to go through a couple of behaviors that are very important for the birds. I don't cover like everything, would be a bit too much. But just to show you what is all included. So we have foraging behavior. So the birds actually spend most of their time of the day on the ground looking for food items, scratching, packing, and foraging. We also have dust bathing behavior, which is actually important to take care of the plumage condition of the plumage itself. And this is something that the birds would do at least once a day, and they often like to do it in groups too. Then we have roosting behavior, which means that the birds go up to the branches of bushes and trees during the dusk phase in the evening, and they do that because this is where they feel safe during the night and avoid predation. And we have nesting behavior, and that includes, at least for the red jungle fowl, building a nest, like looking for a good nest site, building the nest, laying the eggs, incubating the eggs, and then taking care of the chicks. And all of this different behaviors actually is something that you would also find in the commercial laying hen hybrid. The difference is specifically for the nesting behavior that these birds still show so they still want to lay their eggs in an enclosed area, like in a nest place. But what they don't have anymore is broodiness. So this is actually the need to incubate the eggs, which has been selected against. This is not what is wanted in the commercial production, but they still want to lay their eggs in this enclosed area. So of course, the environment that we keep our laying hens today is completely the opposite of what we would have in nature. And in fact, next to the environment, also the flock size is much, much bigger. And we have different types of housing systems for laying hens, and most of the laying hens worldwide are still kept in cages. But there's one system that actually is becoming more popular, specifically in Northern America and also in Europe, and this is the aviary system, which you can see here. And specifically, that system is considered to be very animal welfare friendly because the birds are able to show or perform their behavioral repertoire that I just talked about in the system. And so I want to show you now, within that system, how actually their behavior can be, how they can actually live all the different behaviors. So we have dust bathing that I talked about already, and in an aviary system, this would actually occur. So you can see the arrow, right? Well, so the dust bathing behavior would actually occur in the litter area, which is on basically litter that is provided on the ground floor of the barn. We have the foraging behavior, which actually also takes place in the litter area, as the birds would not only show dust bathing there, but also scratching and pecking, etc. But foraging actually takes place here at the feeding trough. So this is actually where feed is provided automatically. And often you have that spread over this, like in different tiers of the system. So in this system, you also have it on the top floor, for example. Then you have nesting behavior, for which the birds have the laying nests on this area here. So this is where these red curtains are. So this is an enclosed area. It's a bit darker there, and the birds go into the nest to lay their eggs. In the systems, it's like that the floor of the nest is slanted in this case towards the front. So you see this white grid, which this is the nest balcony, and underneath you have an egg conveyor belt. So the eggs would roll onto this egg conveyor belt that the eggs can be collected automatically too. And then you have the perches on top of the system for the birds to perform the roosting behavior. And in the aviaries, you really have perches, most of the perches located at the top tier, because this is, as I said, where the birds want to go. So the birds want to go up during the dusk phase to sleep on the perches during night. So since the market or the egg producing industry is really big, there is also a big need, or a big market for the industry and for companies to build aviary systems. And as you see here on these pictures, it's like a variety of different aviary systems that are on the market. And for the companies, it's of course very important to build these systems to be efficient for the producers. So that means, as already mentioned, automatic feeding, automatic egg collection, and also automatic manure removal. And what these systems also have as an advantage for a producer is, because of their design having these stacked tiers, because of going basically into the height, you have more surface area available. That means you could actually have more birds in a barn compared to if you would just have the ground floor as a surface area. So these are all advantages for the producer too. And what you see here is also, if you look at all the different systems, that they're actually not that similar, not that different, sorry. So you have one of the biggest differences is if you have either the nest boxes integrated in the system, like here, or you have the nest boxes located outside of the aviary. But what they all have in common is that they are quite high. So they are between 2.5 to 3.5 meters in height. And also they are all quite complex because of this design with the stacked tiers on top of each other, and then the resources distributed among these tiers. So that means that the birds really have to move vertically within the system to actually have access to all the resources. So in the beginning, I said that the aviary system is considered to be animal friendly or welfare friendly for the birds, because yeah, you can see they really have a lot of space in terms of like freedom of like movement. They can fly, they can perform all their behaviors that they want to, but there are also downsides. And one of the downsides that is actually associated with aviary systems a lot is keel bone fractures in laying hens. And this topic is actually, or has been investigated over the last years very intensively, and is considered to be one of the biggest welfare issues in the egg producing industry. And this is because of two reasons. So first, we have a very high prevalence of fractures occurring in laying hen flocks, with up to 97% of the birds experiencing any type of fracture. And just for everybody to know what it is, so this is the keel bone of the bird. This is where the wing muscles are attached to. And then you can have a different severity of fractures or deformations that are happening to that bone. So you have on this picture here, this is an X-ray picture of a healthy keel bone, and this, for example, is actually the opposite of the scale that you can have, or at the other end of the scale. So this bone has multiple fractures of different severities and also healing status. So first, yeah, as I said, the prevalence is very high, which is very concerning, but also we know that fractures are painful and that they influence bird behavior as well as the production. So of course, like a problem like that is it has multifactorial causes. So there are different causes that are in discussion, and one of the causes is that is assumed to be associated with that problem are falls and collisions within with housing structure, and specifically that is true for aviary systems. At least this is what is thought of, or what is assumed. And actually, this is actually also a little bit of the assumption is coming from experimental studies that have been done on what the chicken can actually do in terms of moving between perches and between perches or platforms. And one of the differences between the red jungle fowl and the laying hen is also that they're heavier, so the wing load is different. That means that being heavier with the same wing area, that automatically leads to like controlling the lift during flight is more difficult. So and if you imagine like walking, or not walking, but basically moving within an aviary system in the vertical direction, you have different parameters that are actually coming into place. So in this here is like a schematic of an aviary system from the side view. So you have litter, and you have the tier, you have perches. This should be the nest box, and the tier and the upper perches. So when it comes to moving vertically in that type of system, there is direction that is influencing how you would move. And from experimental studies, we know that downward movements are more difficult for the birds to perform than upward movements, for example. Also, we have not only direction itself, but of course we have other parameters, for example, the angle. So when the angle comes into play, we know that, for example, 18 degrees downwards are more difficult for the birds. So they have a higher latency in order to perform a jump compared to 18-degree upwards. You also have the angle itself, as already mentioned. So that means how the perches, for example, are positioned. And so here we know that already like a degree more than an angle more than 30 degrees is problematic when it comes to downward movements. And in terms of upward movements, it's more than 60 degree, which is problematic. And then we have the distance. And from the studies, we know that more than 50% distance may be problematic. And then here again, of course, direction and angle and distance all together can like work together somehow and influence how difficult like a pathway or for chicken is how difficult it is to actually overcome these different directions, angles, and distances. But this is only for experimental studies that we know. So, but then if we know what is actually good for them, so what can they do and what cannot? So if that is something we just apply to commercial settings, I guess we would be safe. But it's actually not the case that this is also applied. So what we did is that we actually went to see different commercial aviaries in Switzerland. So this is 8 different types of aviary systems. And here again, we have the schematic. And what we did was we basically imagined how a bird would move from the litter area to the upper tier. And we would actually measure every little step, like one by one, that the birds would need to be doing. I mean, we didn't know how the birds do that, but we just assumed that this would be a way to go. And so we measured every little step from one step to the other, and we measured the angle and the distance. And in this table, you can see the maximum angle that was measured and the associated distance to this angle. And you see directly that these numbers are much higher compared to the numbers that I just showed you on the last slide. There are also pathways that are less difficult for the birds, but still the numbers in general seem to be much higher in the commercial situation as what we know from the experimental studies, what the birds are capable of doing. So it's not a surprise that perhaps in these commercial systems we have faults occurring. And we were wondering, so is it really a problem? How much of the faults are really occurring? When do they occur? How often and from where? And so we did a study in a semi-commercial barn that we have on site, where we have a barn equipped with an aviary system. And we just actually put a camera in the barn and then recorded what is happening throughout the day and also the dusk phase in the night. And so this is an example of a video that was done during this project. And so just to explain, so this is the same aviary actually that as you saw in the picture. So the light is still on, but it's dimmed, which is why the camera is on infrared. And it's also slow-mo video because otherwise it would go very fast. So in what you're going to see is a bird that is actually falling from the top perch down and colliding with other birds. And I guess this is really this, so it's, I guess it's this bird that is now coming down and then colliding with other birds. And this is just one example. So basically what we found was there are a lot of faults occurring, specifically in the dusk phase. This is just one example, and every fault is basically a bit different. And after actually observing that, we thought, well, perhaps this is an artifact of our semi-commercial barn. I mean, it looks quite commercial, but it's not. So we have pens, so it's not as you would see on commercial farm. So we actually went on 16 different farms throughout Switzerland. And we did the same thing, like we put cameras up in the barn. We collected data at 20 weeks of age and at 45 weeks of age at 4 different times of day. So that was after the lights got on in the morning, during the midday, during the dusk phase, and when the lights were off. And we looked at the number of falls that occurred, how many collisions we found during a fall, the cause of the fall, and from where the faults were occurring. And it was really interesting because we basically found the same results as we had in the experimental setting or the semi-commercial setting. So which was really a confirmation of the findings that we had before. So, and to summarize that, so what we know is that the majority of falls in an aviary occur during the dusk and the dawn phases, in the morning and in the evening. We know that a lot of faults include collisions with a perch or also other internal structures, like, for example, the edge of a tier. We also know that more faults occur in week of age 20 compared to week 45. And we observed that the majority of faults occur from the upper aviary tiers. And so knowing all that, like in terms of what is the pattern, there is definitely a pattern. So specifically the combination of where do the faults occur and when hints towards like these time of days when all the birds move into the same direction at the same time. And that is really in the morning. The birds are all on the top level of the aviary where they stayed for the night. When the lights are on, they all want to go down. And then you have, I don't know, in Switzerland, you have 18,000 birds max, but this is just for Switzerland. So this is actually quite small compared to other flock sizes that you have in Europe. So, but all the birds actually go down at the same time. And in the evening, all the birds want to go up to the back to the perches. And this is where you have the bottleneck, you have a lot of traffic going on, and this is where the faults are occurring. We were not the only ones studying faults or failed landings. It's often also called failed landings. So this has been confirmed by other studies, also in commercial settings as well. So a bit to summarize, so faults are, of course, we started studying that because of the problem with the keel bone fractures. But like after realizing what is happening, we thought this is really like a problem on its own. So having these high rate of faults, including collisions within the aviaries. And the causes for the falls, I mean, there are also different or various causes included. Like, for example, the perch design may be a problem because specifically the perch that is used the most is the round metal perch. And this perch, depending on, for example, if it gets wet or like with feces on it, it can get quite smooth. So it's slippery for the birds. We know already about the distances and angles that the birds can use or can do, and which are not level that is not appropriate anymore. This is what I talked about. And we also know that this is actually not really applied, or these safe distances and angles are not applied in the commercial setting. It could be related to poor navigational skills, and specifically here the rearing phase is very important, and if the birds are not prepared for that, then you may have problems later on, and this is also something that Alex is actually mentioning later. And we have the bird density. This is what I already mentioned in terms of the flock size, which is really a lot of birds in a barn, and then having these time points of the day where everybody goes into the same direction. And that's so already mentioned, of course, falls and collisions are hazardous for the keelbone health, but in general, we think it's a problem on its own, as it potentially is imposing stress and discomfort for the birds. So when we actually found out about all of that, we thought, well, then we need to do something in terms of improve the design of an aviary in order to reduce falls and perhaps by that reduce keelbone fractures as well. So what we did again, or not again, after, we had the original design of an aviary, and then we actually tried out two different designs. So one group was where we included rams in the system, like here, as you see in purple. And then we also had another treatment group where we had, instead of the perch in front of the nest, we had a platform. And we collected data like in terms of behavior, like moving, how the birds would move in the different designs, as well as on keelbone health. So we collect data on individual birds for like one laying period, like more or less a year. And the result is basically that we were able, with the two different designs, we were able to increase the vertical movements. So in the ram treatment, it was about 44% more vertical movements within the system. We could reduce the number of falls as well as collisions. And also we had fewer fractures until 60 weeks of age in the ram treatment. And then also for the platform treatment, we were able to increase the number of movements and reduce falls, collisions, and fractures. So with the ramp design, we intended to provide a continuous path for the birds to walk vertically within the system, which obviously worked. And also for the platform here, the intention was to provide a platform which we thought is easier for the birds to land on compared to a perch that they would be where we assumed it would be more difficult to actually land on. And yeah, and also this design was quite beneficial for the birds. So that was actually published in 2015, and afterwards there were other studies that actually focused on rams. And this is just one study that was done in the Netherlands, and also just to sum it up a bit. So you see here, they also had a look at keelbone fractures, and they also found the same effect, that with the ramp design, or this was, I guess, a semi-commercial setting as well. And so they were able to reduce keelbone fractures with the ramp design as well. And also they had a look at foot pad health, and they could show that using rams is reducing or is actually beneficial for the foot pad health as well, because they found fewer hyperkeratosis, footbed dermatitis, and fewer bumblefoot in the birds that were provided with rams. So the studies showed that rams are beneficial for the birds. And this is just, so with this slide, I just want to give you an example of how the knowledge and the research that has been done can be used actually to apply to apply it on farm, and to use it in order to to apply it basically. And this example is from Switzerland, where rams are mandatory for some aviaries, and specifically the high ones with integrated nests. So these systems have to have rams. And the rule of thumb here is to provide a pathway in the system to offer birds walking instead of jumping and flying. And I guess this is just a very nice example of how you can use results from with a scientific like an experiment, and you have nice results, and then just to use it in order to actually do something with it and like improve upon something. Yeah, and now I hand it over to Alex. He will be talking about the rearing phase and using ramps there, as this was, of course, the next step to actually look into that phase, because this is a very crucial phase for laying hen development. And then we were interested in how ramps would do in that phase as well.
Yeah, yeah. The laying and we can see that in here when the birds are around, like until the birds are constrained to the first year, so that they are close to food and the water source as well as heat source, and they're constrained in this first year until 3 or 4 weeks of age, and after which they get access to different parts of the aviaries. And also one challenge in the aviaries is the difference in the physical and cognitive abilities of the birds to move within this system during different ages. And it's also a general consensus that hens should be reared in houses that are similar to the ones that they will be housed as adults for various health and welfare reasons. So with more and more with laying hen industry transitioning towards cage-free systems, you also have more chicks being raised in aviaries. And as we know from many studies on a variety of animals, that early life has a huge impact on development of various traits of an animal. And rearing in a complex system such as aviary that provides access to three-dimensional space as well as increased opportunities for load-bearing exercises has been shown to improve the skeletal strength of the animal as well as improve the spatial cognitive capabilities of the birds. And also rearing in such complex environment has a long-term benefits that gets carried over to the laying phase, where we see that birds have few keel fractures, as well as birds are less fearful and use three-dimensional space more when they are reared in aviaries. Given all the welfare benefits of the rams, it's also a complex environment, especially when the birds are really small, where you have a mismatch between the physical and cognitive abilities of the birds and the environment in which they are raised in. And of course, one obvious solution is to provide them a continuous path that connects the different vertical tiers of the aviaries. And this is where we try to put, install ramps into the rearing houses. And installing ramps during into the rearing houses has been shown that you have more number of birds on the top tier when the birds are small, and you see this trend holding true even when the birds are old, like when the birds are 11 weeks old and 15 weeks old. And when they're small, you can they lack the physical ability to jump or fly between these tiers. But when they're 11 or 15, they have the physical ability to jump between these different tiers. But you see that the birds given access with ramps, you see more number of birds on the top tier when ramp access is provided. And you also see a more number of transitions between tiers when birds are provided with ramps. And this is especially pronounced when the birds are young, when they lack the physical and behavioral ability to jump or fly. But you also see the similar trend of a number of transitions are more in the ram reared group at ages where they have the physical capability to jump and fly. And if you look at the ram reared groups, we see that when the birds are small, almost 100% of the transitions happen through rams. And when they are more older, like here in the 14th week, you still, like when the birds have this ability to fly or jump between tiers, you see that birds use the rams for moving between the tiers. And so this really shows that birds have a preference to use ramps to navigate the aviary vertically. So this is the study that looked into where the birds are reared with rams, and then the birds are transferred to the laying house. And even when the birds are transferred to the laying house, we see that birds prefer to use rams for transitions. As here we see that there's more number of transitions that happens in a ramp area compared to a non-ramp area. And this holds true for both the directions. But if you look at the directions, you also see that there's more number of transitions happening using ramps in the downwards directions. Like if you call back to what Ari was telling, like going down for a jumping down for a bird is way more trickier than moving up. So in here, the direction also plays an important role, and birds prefer to use ramps more when they're moving down. You also see a benefit of rearing with ramps that gets transferred all the way to the laying phase. So in this study, we have here the gray color represents the birds that are reared with ramps, and the orange color represents the birds that didn't have access to the ramps. And this here is the data, like the x-axis is the number of hesitancy behaviors. So this behaviors such as crouching or pacing, which are indicative of hesitancy before the birds are doing a transitions. So in here, you have these two treatments, and then the birds are transferred to the laying house where the birds have access, all the birds have access to the ramps. And you see that the birds reared with ramps show less number of hesitancy behaviors before they use ramps for a transitions. And you see that at 17 weeks of age, and when you go into like 24 weeks of age, you see that there's an overall reduction in number of hesitancy behaviors. So this really adds on to the fact that experience with ramps is really important for the birds to learn how to use the ramps. And especially when you want to transfer a birds towards the aviary system. So it's really important that you rear the birds in an aviary system with access to ramps so that they know how to use the ramps when they're transferred in, and then make the transition towards the laying house a bit more smoother. And we also have observed long-term benefits in terms of the number of keel fractures that you observe for the birds, with the birds reared with ramps showing 52% of keel fractures at 40 weeks of age, compared to 64% of keel fractures at 40 weeks of age for birds reared without access to ramps. So this here is a data that comes from palpating the birds to look for keel bone damages. So we can also look at keel fractures in detail. So this scale here represents like X-rays from keels, and then this is a scoring system here with 0 representing no fractures and 5 representing multiple fractures. That's a severe amount of fractures for the birds. So we have a 2x2 factorial study where we looked into the amount of keel fractures that happened with providing ramps during rearing and lay. So this here are the results for the severity of the fractures, and this here are the 4 different groups. So this here is a group with ROLO, meaning there were no ramps during rearing and there were no ramps during laying phase. And in here, this is the group where birds had ramps during rear, and here the birds only had ramps during rear. And this is where the birds only had ramps during lay, and this is where birds had ramps during rear and lay. And if you look at really where the median of the severe fractures are lying, we see that rearing, providing ramps during the laying phase is more critical in terms of reducing the number of keel fractures. And given all this welfare benefits of the ramps, and when you want to put out the ramps into an aviary, you also have to think about how can we design the ramps by understanding the behavior of the birds. So this is a study that looked at 2 different designs of ramps. So the A here is a ladder design, and B here is a continuous grid design. And for these graphs, the continuous line represents the data from the grid, and the dotted line represents the data from the ladder ramp. And then you see that birds perform more number of transitions when they have a grid ramp compared to the ladder ramp. And this is true for both the directions, upwards and downwards. And if you look at the number of birds that stay on the ramps over amount of time, and this here again is the dotted line comes from the ladder ramp, and the continuous line comes from the continuous grid ramp. So you have more number of birds that stay on the ramp when it's a ladder design. So when you want to consider ramp as a continuous path that provides access to the various vertical tiers of the aviary, you need that path node to be blocked. And we see that just looking at the grid design, you have more number of transitions, and you also that the grid design also remains to be this unblocked continuous path. So this way, we need to really try and understand the behavior of the birds to design the ramps effectively. And especially talking about the incline of the ramps is critical because you have birds with different ages during the rearing phase and the ability of your birds to navigate this different inclines changes with age. So we have this nice study here from Leblanc, who looked at the ability of the birds to negotiate different angles. So they looked at the ability of the bird to climb up an incline surface to access a food resource on top for angles starting from 20, and they looked at the angles all the way up to 70. And the important finding from that study is that for all the birds from week of age 2 to 36, all the birds were able to climb up an incline up to 40%. So this is an angle that all birds can negotiate at all different ages. So this is only for upward transitions. So you also have a nice study from their group that looked at the downward transitions. And it also shows that for downward transitions, 40-degree is an angle where birds of all age can negotiate easily. So thinking about, given all this welfare benefits and design of the birds, we can also look at how do you maximize these benefits. So this is where I did a few experiments where I tried to use artificial cues that are easily applicable to a commercial setting, but are inspired from the biology of the bird to improve the ramp usage of the birds. So in this here is one such cue that I used, and I call this cue the daughter cue, because it's just a yeah. So sorry. Yeah, this here is the daughter cue. As you can see, this is like a small light dot that goes up and down. So through this cue, what we try to like tap into is the innate predisposition of the birds to moving objects, and also a predatory instinct of the chicks to peck at small moving objects. So we try to design a cue like that. And then we had a second cue called the flicker. And we developed this cue based on a set of research that happened during the 70s, looking at what kind of light elicits an approach towards an approach behavior in chicks. And you see that at 4 flashes per second, and when elicits an approach preference in birds. So we try to put that cue into one of our treatments, and this is how it looks. And you can see that both the cues differ so much in their intensity. And then we looked at various behaviors in terms of RAM usage for both of these cues in regards to control treatment. So this here is our results from the transitions between tiers that happen through ramps. So this is when the birds move up a tier or go down a tier using the ramp. And this here are for the control treatment that didn't have any light. And this is the dotted treatment where you had the small light dot that moved up and down. And this here is the flicker treatment. And the box plots represents the raw data, and the line plot with the ribbons represents the model predictions. So one important thing is that we gave the birds access to the ramps from second day of age. And we have data from the third day and fourth day where we saw almost no transitions happening at that age. And from here, the data is from the 10th day of age where the transitions happened. And we see the slight increase in the amount of transitions performed, at least in the daughter treatment, although non-significant. And but we also looked at the active behaviors that happened on the ramps without any transitions. That is, the birds actively using the ramp, such as running on the ramps, performing wing assisted incline running on the ramp, or jumping to and fro from the ramps. But that didn't actually result in a transition. And in here we see that we have a trend where birds tend to use birds tend to use the ramps actively when the cues are on. And we also see that there's more number of active behaviors happening in the flicker treatment when the cues are on compared to when the cues are off, at least until 41 weeks of age. And we also looked at the long-term impacts of this on the spatial cognitive capabilities of the bird and bone biomechanics of the birds. And this is something that we are still looking at. So, oh yeah, one important factor that I also wanted to mention was so this year, the data from the red box. So the red box here is the data from day of age 3 and 4. So at day of age 3 and 4, if you remember from the number of transitions that you didn't really have any transitions that happened during that time. But then you see that birds are actively using the ramps on day 3 and 4. So this shows that birds show this nice behavioral progression where birds are slowly exploring out and learning how to use the ramps. And then you see this ramps getting picked up from like number of transitions getting picked up from second week of age. So with that, I come to like some conclusions from the research that we have done, and also the research that's been happening out in regards to aviary design and in regards to ramps. So it's like ramps have like immense welfare benefits both during the rearing phase and laying phase, especially improving the access to various resources that are differentially located across the vertical tiers of aviary. And we also see that a lot of these benefits carrying over to laying phase, where you see this less number of keel fractures and less foot disorders, etc. And like one of the most important aspects also when you design housing for birds is to try and design it from what the birds need, like by understanding the preference and needs of the birds. And we see that both during rearing and laying phase, birds prefer to use ramps for transitions, for moving up and down different tiers. And we also think that there should be like more research in commercial setting, especially because like a lot of research that happened during like in the rearing phase comes from small experimental setting, and this is different from commercial settings where you have higher aviaries and more number of birds. And we really need research on commercial settings so that you can increase the applicability of this results. And it's also important that we maintain communication with the industry who are in the forefront of implementing the research findings. So it's important to convey the results and work with the industry to try and implement the research and try and put it out into commercial settings so that it's beneficial for the birds. And there's also it's a complex structure, and there are many other design parameters that you have to think, like what should be the bird space on the top tier when you consider the number of falls from the top tier, and how should we better design the aviaries? How does the movement differ between aviaries that are more wide than more high? And there are and what should be the angles and what should be the heights that the birds can navigate? How does it change with different age? So there's a bunch of other things that we really have to look into, like the various other structures of the aviaries that still need small amount of research. With this, thanks everybody for listening to us. And we also thank all our group members, technicians, and the facility where we do our research, and the funding agencies that really gives us the money. Thank you so much.